Okay, so let's talk about this Khan Academy problem um, where we're trying to use a simulation to come up with an approximate p-value. So an economist read a report that claimed that 60% of residents in her large city own their homes. She wondered if that figure was still accurate, so she took a random sample of 50 residents in the city and observed that p hat, so the sample proportion, was 70% of those sampled own their homes. To see how likely a sample like this was to happen by random chance alone, the economist performed a simulation. She simulated 100 samples where the sample size each time was 50 residents from a large population where 60% of the residents own their homes. She recorded the proportion of residents who own their homes in each sample. Here are the sample proportions from her 100 samples. So that dot plot has 100 dots on it. Each dot represents a sample of 50 residents. And we are recording the proportion of residents in that sample who actually own their homes. Now, this is our simulation under the null, where the null is that the true population proportion of residents who own their homes is 60%. Okay. She wants to test the null that P, the population proportion, equals 60% versus the alternative, P does not equal 60%. So we don't know which direction this is going in. It could go in either tail. It could go left or right. We have to look in both tails when we're trying to come up with the p-value. P is the true proportion of residents in the city who own their homes. Okay, based on these simulated results, what is the approximate p-value of the test? And note the sample result was p hat is 70. That's really important information. So when you look at this distribution, this is our simulation. Our sample ends up right here at 70%. Okay, a p-value is the probability that we would observe a sample as extreme or more extreme than the one we did if the null is true. We are trying to figure out if the null is true, that 60% of residents own their home, what's the probability we would obtain a sample of 70% or more extreme? And that difference has to go in both directions. So the first thing we want to think about is this. What is the difference between 70, our sample proportion, and 60, our null proportion? 10. So that actually means we are trying to look like 10% away from the mean in both directions. So first, think about where your sample is. Your sample is at 70%. So we start to count our dots. We're trying to figure out how many dots are 70% or more extreme. How many dots are 70% or greater? So that looks like 1, 2, 3, 4, 5, 6, 7, 8. That's 8 dots. Okay, but coming back to the alternative is talking about finding a difference. And that difference can go lower or higher. So we actually now have to look in the other tail. 60 is the mean of our distribution under the null. We now need to look 10 lower than that. We need to go down to 50, and we need to figure out how many dots are at 50% or more extreme in the less than direction. So 50% or lower. So we're counting up these dots. That looks like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. That's 13 dots. Putting those together, 13 plus 8, that is 21. So there are 21 samples in this distribution of 100 samples total that are as extreme or more extreme than the one we observed, meaning there are 21 out of 100 dots that fall at least 10% away from the mean, either less than or greater than in both directions. So the correct answer is actually D, where the p-value is 0.21.